Let's solve the exercise together now. We are asked to evaluate the magnitude, okay, because we know that if we are given a vector r, okay, the magnitude of the vector is given by this. So when whatever is changed in between them, okay, this is a vector and we are asked to evaluate the magnitude. This is a vector and we are asked to evaluate the magnitude, and this is a vector and we are asked to evaluate the magnitude. Now we are given three vectors, okay, that's the question, and the question asks us to evaluate the magnitude of each, and we know that the solution to this, okay, is this. Now let's begin with question 1. We are asked to evaluate the magnitude of 2a plus 3b minus c, and from the end, from our previous exercise, we know that 2a plus 3b minus c is equals to minus I, okay, minus j plus 21k. So minus I minus j plus 21k. Now with that done, let's go back again and see the meaning of the magnitude of vectors. So we have r is equals to xi, which I'm sure you're familiar with, plus yj plus zk. The magnitude of a vector is regarded as the square root of the sum of the individual squares. Let's say it again. That's the magnitude of a vector is regarded as the square root, okay, of the sum of the individual squares. So the individual squares are x squared, okay, plus y squared plus z squared. So comparing that to the question given, so this results into the square root of minus 1 squared, okay, minus 1 plus another minus 1, which is a component of minus j, and plus 21 squared, which is a component of k. All right, so if we resolve this results into 1 plus 1 plus the square of 21 is equals to 441, and this is equal to root 443 units, which can be written as 21.048 units. Moving on to question 2, we are asked to evaluate the magnitude of a minus 2b. Question 2 is here, a minus 2b plus 4c. And we know that the solution to a minus 2b plus 4c with respect to our previous exercise is 15i plus j minus 7k. So it is equal to 15i plus j minus 7k. And we are asked to evaluate the magnitude. So therefore the magnitude is equal to the square root of the sum of the individual squares. So this is 15 squared, okay, plus 1 squared, okay, 1 squared, and this will be minus 7 squared. This results into 15 squared, which is 225, plus 1 and 7 squared is 49, and this is the square root of 240 units, and approximately 15.492 units. And finally, let's solve the magnitude of question 3, which is the magnitude of a minus b minus 3c. And a minus b plus 3c minus 3c is given as it's minus 18i, okay, plus 12j minus 2k, minus 18i plus 12j minus 2k, and this will result into the square root of minus 18 squared plus 12 squared plus minus 2 squared, because it is the square root of the sum of the individual squares, and our resulting expression will give us 324 plus 114 plus 4. This results into the square root of 472 units, which is approximately 21.726 units. Now these are the magnitude. So in conclusion, if we have R, okay, can be a column vector of x, y, z, and this column vector can be written in terms of component form of unit vectors to be xi plus yj, okay, plus zk, and this will result, and the magnitude, okay, the magnitude of R will be equals to x squared plus y squared plus z squared. The same thing applies if it is a two-dimensional vector. If R is equals to xy, the components, the vector in terms of components of unit vector will be xi plus yj, and the magnitude of this will be given as the square root of the sum of the individual squares, which is square root of x squared plus y squared.